Today I'm going over the installation and setup process for the Fusion 360 Parametric Component Add-In. We'll start by going to STS3D on GitHub, then navigate to the Fusion Parametric Component Add-In repository. On the top right of the page, you'll click the green code button. You'll have two options here. You can either copy the URL and clone the repository using terminal, or download the zip file. Select the folder you want to download the extension into. You might want to create a parent folder for all your custom extensions, but this is optional. Navigate to the folder you downloaded the extension into and unpack the zip file. Now you'll see the top level directory called Fusion Parametric Component Master, which contains the actual add-in, which is called Parametric Component. Now open up Fusion 360. On the top of the page, you'll click onto the Utilities tab, then click the Add-ins button. You can also press Shift-S to open the Add-ins window. You'll see two tabs, Scripts and Add-ins. Click on the Add-ins tab. Here you'll see all currently installed add-ins. To install the add-in we just downloaded, we'll click on this green plus icon. Now navigate to the directory where you downloaded the zip file. Make sure you select the folder inside the downloaded folder. This should be on the same level as the README file. Click Open. Now you'll see the add-in in the list of installed add-ins. Click the Run button on the bottom of the window. Now in the Utilities tab there will be a new icon for this add-in. If you click the drop down, you'll see two options, Create Components and Delete Components, which I'll explain more about later. If at any point you encounter any issues, go back to the Add-ins window, click the Stop, then Start buttons. This will restart the extension. The easiest way to explain how this add-in works is with an example. So let's say we want to create 50 uniquely sized boxes, each with a different length, width, and height. We also want the dimensions of the box displayed on the top. We'll start by saving a new design, then create a new component called Box Master. Next, create a sketch on the XY plane. We'll first draw a square, then set the length and width to any arbitrary values. Now we'll add text to the sketch, which we'll call Text1. We'll constrain the text box to the corners of the square. Exit the sketch and extrude the square to some arbitrary height. Now we'll extrude the sketch text 5 millimeters higher than the box height. Make sure to use a join operation here. Now we'll go to the Solids tab, then click Modify and select Change Parameters. Here we'll expand the sketch text and extrude operations so we can see all current model dimensions. We'll then rename the three dimensions, length, width, and height. We'll set the text extrude height to be 5 millimeters more than the box height and set the text letter height to be a fraction of the box length. Now we open up Excel and create our column headers. The actual name and format of the column headers only matter if we want the add-in to automatically map the columns to each parameter. If the name doesn't match, we can select them manually in the next step. In general, column names should be in the form of object.attribute. The first column sets the name of each new component, so the column header should match our master component name, in this case, box master. And since it sets the name attribute, we add a .name to the column header. Next column sets the length model parameter, and since we are setting the expression value, we use length.expression. We do the same thing for width and height model parameters. Since sketch text objects cannot reference parameters in Fusion 360, we refer to this object by its text value with the text attribute, in this case text1.text. Now that we have the headers finished, we'll fill in the table values. Since this is Excel, we can use formulas to speed up this process. We'll set the component name column to box-row index number. For length, width, and height, we'll use the random range function with integer values between 50 and 100. The sketch text will display length, width, height with their respective values. Now I'll drag the formulas down to create 50 rows, and we'll save the spreadsheet as a CSV and go back to Fusion. In Fusion, we'll go to the Utilities tab, then click on the Parametric Component icon. First, we click the Select Spreadsheet checkbox. This will open a file dialog where we select the spreadsheet we just created. Then we'll select the master component. The first two tables will display attributes and parameter data from the master component. The columns in red are drop-down menus where we can manually select which values should be mapped. Since we use the proper naming convention, we should see our parameter values in the bottom table. Next, we select the sketch text from the sketch object. Again, we should see the table values auto-populate. If we want to save the new components as an STL, we'll click the Export STL checkbox and then select the output folder. Double check all the mapped values, and if everything looks good, we'll click the OK button. Now the add-in will begin creating the new components. This may take some time. When it's all finished, we see the new components in our design. And if we go to our output directory, we will see all the newly created STL files. Finally, we click the Delete Component button to remove all these new components. Keep in mind this is currently a very beta release, and I do have many improvements planned in the future, so please let me know if you have any suggestions or encounter any issues while using the add-in.